Friends, welcome to my YouTube channel. Dhanesh here. Today we are going to discuss about Z score. See, this is the seventh video on feature engineering. In this video, we are going to discuss about Z score. Let's start. So, Z score it is used to detect the outliers. Before getting into Z score, let's have a quick introduction to feature engineering. Feature engineering it is it is used to the goal of feature engineering is preparing the proper input data set, improving the performance of the machine learning model. You know it. Now we are see what is the purpose, what is feature engineering. It convert data into features. In feature engineering we convert data into features. These are all the list of techniques used in feature engineering. Imputation we already discussed, that is handling missing data. There is a video in the playlist, you can watch it. Handling outliers, that's what we are discussing now. The last video we discussed, it was uh, box plot, it is our whisker plot, it's already done to detect outliers. And in this video we are going to discuss Z score, binding, lock transform, on hot encoding, grouping operations, feature split, scaling, extracting data. These are all the topics we are going to cover as part of feature engineering. Now, before getting into the Z score, I want to give you an introduction about outlier. In statistics, an outlier is an observation point that is distant from other observations. These extreme values can be present in both dependent and independent variables. If it is coming in the dependent variable or target variable, it's known as an outlier. These extreme values are coming in a target variable or dependent variable, it's known as an outlier. If these extreme values are present in the independent variable, those are all the points of high leverage. Fine. Finding outliers, we have box plot. Sorry, we have the sorry, it is yeah. We have the box plot, we have the scatter plot, Z score, IQR score, and Cook's distance. These are all the methods we use in we use for finding outliers. See, box plot and scatter plot are visualization tools. Z score and IQR score are mathematical functions we use here. So box plot it is already covered. Here we are going to discuss about Z score. IQR score means intra-quartile score, intra-quartile range, that is IQR score. See, to understand, I know this Z score, because normally we use Z score for normal distribution. It's also known as Gaussian distribution. It is a probability distribution that is symmetric about the mean. That's all. This is the point you need to understand. Symmetric about the mean. If the data points are symmetric about the mean or the median, such distribution we call it as the, such distribution we call it as a normal distribution or binomial distribution. You are getting it. See, normal distribution is also known as Gaussian distribution. If the data points are symmetric about the mean, it is known as it. The graph should be a bell curve. If you plot the graph, this is the mean, and these points we can call it as the outliers here. Fine, you understood that. Z score. Z score is also known as standard score, gives you an idea of how far from the mean a data point is. But more technically, it's a measure of how many standard deviation below or above the population mean a row score is. So Z score, it's known as standard score. It gives you an idea how far from the mean data point is. Z score is measured in terms of standard deviation, because I will give you the formula. At that time you will understand. Z score is in terms of standard deviation gives the spread of data, right? You can learn that because there is a video in the playlist. You please watch it. If Z score is 0, it indicates that the data points are identical to the mean score. If Z score is positive or negative, Z score can be positive or negative. Positive value indicates that Z score is above the mean, and negative value indicates that it is below the mean. This is the mathematical treatment for Z score. Z is equal to x minus mu by sigma. X is the data point. Mu is the mean. Sigma is the standard deviation. Standard deviation, as you know, it's a number used to tell how measurements for a group are spread out from the average or the expected value. So this is the mathematics of Z score, x minus mu by sigma. X is the data point. For example, if you have a mark, John's mark is 70 and its a mean mark is 60, then if you have the standard deviation also, you can calculate the Z score for John. That's all. It will be 70 minus 60 by standard deviation. Simple. These are all the characteristics of Z score. A positive Z score says that the data point is above average. A negative Z score says that the data point is below average. A Z score close to zero, this is not a Z score close to zero says that the data point is close to average. A data point can be considered unusual if Z score is above 3 or below minus 3. This is very important. If the Z score is above 3, it's an outlier. If the Z score is below minus 3, it is, it's an outlier. That's the way we calculate. It's really important. Now you need to understand. I will be, giving you a program. So I will show you a Python program. It's I am running the program in Spider. I have the Anaconda. On top of that, I have, from that you can, run the Spider IDE. When you type Spider, you can get this IDE. This is a simple Python program. I am importing NumPy as NP. Then you have the data 1 2 2 2 3 1 1 15 2 2 3 1 1 2. After seeing the data itself, you can understand 15 is the outlier there, right? It is shifting lot from the mean. So I am using the NumPy to calculate the mean. nb.mean function, the method I am calling. Standard deviation also I am calculating. The std method I am calling from numpy. I can print the mean and the standard deviation. Then I am taking the threshold as 3. Then the outlier, it would be, I am storing it in an array. Then for I in data, I am calculating the Z score. That is I minus mean by std. I is the data point. Mean we have already got it. Above we got it. Standard deviation also we got it. If Z is greater than the threshold, that is 3, then it's an outlier. We are appending to the outlier there. So the print outlier. So this is a very simple Python program. When you run it, see, I have already run it here. I can run it once again. Then you will get this. How it is. I can already. I'm running it again. Then you can see here. See, it's printed the data set. The mean it is printing. It is 2.666 something. The deviation is also it is 3.3598. It's going like that. Then the outlier it is it is shown it as 15 is the outlier here. This is a simple Python program. It's simple. It's really very simple Python program. Now I am in the next video I will be giving IQR score. So how you can intra-quartile range, how you can use the IQR score to find out to detect the outlier. That will be covering in the next video. So we discussed box plot or whisker plot. In this video we covered Z score. In the next video I will be covering IQR score. So thanks a lot. Please like, share and subscribe. Thanks a lot. Thanks for watching. Thanks a lot.